Hello, today I'll be going over another problem from Energizing Physics Lesson 4.5. So this question asks, if Miranda bends down and jumps straight upward, what will her motion graphs look like given the velocity versus time graph? So the first graph we'll draw is acceleration versus time. Since we're given her velocity versus time and we know that the acceleration is basically just the slope of the velocity versus time graph, we'll look at certain coordinates. So the first period we can look at is from 0 to 0.2 seconds. And we see that the acceleration is going to equal delta v over delta t, which is equal to negative 1.5 over 0.2, which is equal to negative 7.5. Next, we look at 0.2 seconds to 0.3 seconds, and we know acceleration will be 0 because the velocity doesn't change. And then the next period we look at is approximately from 0.3 seconds to 0.55 seconds. And we see that the velocity goes from 3.5 minus negative 1.5 to, and the delta t is 0.25. So this is equal to 5 over 0.25, which is equal to 20 meters per second squared. And then the final period we look at is 0.55 seconds to 0.9 seconds. And we know that the delta v is going to be negative 3.5 and delta t is going to be 0.35. So a is equal to delta v over delta t, which is equal to negative 3.5 over 0.35, which is equal to negative 10 meter per second squared. So now we can go to that actual graph where we will plot this. So we're just filling in the increments right here. And a good increment to use would be 2.5. So between 0 to 0.2 seconds, we are at negative 7.5. So this is the magnitude of our acceleration. And then from 0.2 to 0.3, we go to 0. So that's this period here. And then at 0.3, we go to 20 meters per second until 0.55 seconds. So that's up here. And then at 0.55, we come back down to negative 10. And we continue all the way to 0.9. So this is our acceleration versus time graph. It's pretty chaotic. But next we will do F net versus time, and we can examine our accelerations using and to get F net, because F net equals ma, and we know Miranda's mass is 50 kilograms. So from at the same period, from 0 to 0.2 seconds. So one trick to drawing these graphs is we know the general shape of F net and A will be the same because they're directly proportionate, and the slope, the only difference is the mass. So we can draw the general shape again. So if we go from the labels, from 0 to 0.2, it's going to be negative here. And then from 0.2 to 0.3, it's going to be 0 again, because that's what we saw from the acceleration graph. And then from 0.2 to 0.55, it's going to be at its max. So 0.3, this is 0.5, so 0.55 is here. and then it's gonna come all the way down again, all the way till 0.9. So that's going to be the shape, because it's going to be the same shape as acceleration, but the magnitudes will plug in using multiplying by mass. So when acceleration was negative 7.5, we'd multiply 7.5 times 50, which is the mass, so that's negative 375 newtons there. And then at 0, it's going to be 0, and when it's at 20 meters per second squared, we're going to multiply 20 times 50, which is going to be 1,000, which is its max newtons. And then when it comes back down to negative 10 meters per second squared, that's going to be negative 500 newtons. Now, next we're going to draw the position versus time graph, and for this graph we're going to just use the initial velocity versus time graph that we were given in the beginning. So with this, we're going to use the areas under the curve. So we look at from 0 to 0.2 seconds, we can see that the triangle area is going to be 1/2, 0.2, and then 1.5. And this is going to be a negative, equals delta x, which is going to equal to negative 0.15. And then from 0.2 to 0.3, it's going to equal to 1.5 times 0.1, which is equal to delta x, which is negative 0.15 again. And then from 0.3 to 0.4, we're going to see a delta x of 1/2, 0.5, 0.05, I mean, and then 1.5, which is going to be half of them, which is negative 0.075, and then from 0.435, sorry, this is 0.3 to 0.35, and then from 0.35 to 0.55 is equal to 1/2, 0.2, and then 3.5, which is equal to 0.35 delta x. And then from 0.55 to 0.9, it's equal to 1/2, 0.35 times 3.5, which is equal to 0.6125. So those are the numbers and the delta x's, and then we plot them in the graph to obtain the x versus time graph.